and welcome to episode 6 of the actual Astronomy podcast. I'm Chris, and with me, as always, is Shane. How's it going this week, Shane?
It's going good. I figured out something.
Oh, yeah?
Not to have a handful of peanuts before we start one of these things, so I don't start choking as I begin talking, which I think happened for the first 2 or 3 podcasts that we did together.
Well, you are going a bit nuts, probably staying sequestered in your home for this length of time.
Yes, that is very true. No stretch at all.
Yeah, good stuff. So, and a bit of a caveat. So we are recording like in our homes, although I have my own office. Are you in your own home office? Is that like a home office that you're in?
Yeah. We have a spare bedroom in the basement that is kind of a home office / telescope storage room, and there's all sorts of odds and ends in here.
Well, my spouse and I, we each have our own home offices. In fact, when I moved to Saskatchewan, as you know, I kept my job and worked here remotely for a company in Ontario for 3 years. I was in this office and then have sort of gone back to that during this time. But I'm on the second floor of my home, and I live in a residential area, which is moderately condensed with people, though like you can go out for a walk these days and not run into anybody, but it's a neighborhood very similar to yours. And currently, across the street, a gentleman is building a very large wooden box in his driveway. So you're going to hear, I was hearing some pounding towards the end of the last episode. We kind of do 2 back to back, and then I had to go and take a peek out in between when we take our break, and I looked out, and he has got probably about a meter by maybe 1.5 meters high wooden box under construction. He is wearing his mask because he's outside, but he's also doing a lot of sanding. So it was indeterminate if the mask was for coronavirus protection or for the sanding. So so that's happening as well. So I don't have a mask yet. How about you?
I'm not wearing one. I have some in the garage that I've bought in the past, for similar purposes as your neighbor across the street to, put on when I'm doing some woodwork or sanding in the garage. But that's really all I have.
Yeah, I'm not much for like putting something over my face. That's just, so, we're not going to be going out in public. I think it's probably okay if we just go walk around the streets, but I'm not going to be going out anywhere anytime soon. Like if we still have to wear masks, I think I'm just staying home for that period of time. So.
Well, and you and I both wear glasses, and, wearing one of those masks sometimes is just a headache with glasses because your glasses fog up because, the air you're exhaling sometimes gets channeled upwards. And
oh, yeah. And
it drives me crazy.
I have so much trouble not touching my face anyway that I know if I'm wearing one of those, I'm just going to be hands on face 24/7. And so it's going to be far worse for me to have one of those on. Absolutely, for sure, 100%. I just could not stand to have that on my face. So that's actually probably one of my greatest concerns about this whole pandemic thing is actually having to wear a mask because I just don't want to do that.
Well, and I'd also have to shave my beard, and if I did that,
right.
I don't know if my wife would even recognize me anymore. So
I would
too risky.
Recognize you at this point. So this week we're going to do what? What are we talking about this week?
We are talking about, I believe, is it the episode where we talk about what's in the sky? No.
We're gonna do a bit of an orientation of the night
sky. Right. Sorry, I was thinking the spring what's up, but that'll probably be the next one.
No, that will be the next one or the one after or something like that. We're keeping this fairly informal. We did this before, like we said at the very first podcast, and we put a lot of work into it, and a lot of that work seemed to be not necessary. So we're not doing that this time. All right. So this one, we're going to talk about a bit of an introduction to the universe. I'm going to go over the entire universe here in about 5 minutes, and then talk about some of the stuff that's in it, or everything that's in it, actually. That will be the next 5 minutes, and then we'll be done. So
Oh,
it
wow.
shouldn't be a
Whirlwind.
problem. So yeah, I mean, one of the things, the universe as we see it from Earth. So we start at Earth and we slowly kind of zoom out. We have the Earth and we have the solar system, and at this time, I think. And you'll recall this, like we've done public outreach events where we do that solar system on the toilet paper, right?
Yes, yes.
Don't you regret not saving some of that toilet paper at this time? Sort of to reference back to
Yes, yeah.
the old
Good.
Corona.
Very topical. It's
Very very
yeah.
topical. Or maybe having not toilet papered one or two more houses in our youth. Okay, so we have the Earth. The Earth is in the solar system, and most people are familiar with this. So inside the solar system, this is like basically our backyard. We've sent probes throughout the solar system. Now it's visited probes have visited all the planets, and our planets are coming out from the sun. And the sun is, so you're actually more of a solar observer than I am. So maybe we'll start at the center of our solar system at the sun, and I will get you to describe what the sun is exactly, since you look at it a lot more than I do.
Yeah, I like to look at it typically with a hydrogen alpha filter, so you can see some of the surface detail and some of the prominences coming off of the sun. But what the sun is the closest star to Earth, which I think sometimes when people are thinking about the closest star, they're thinking of Alpha Centauri or stars that you see in the night sky. But the sun is the closest, and what's very interesting about the sun is it's a very common star. Kind of, it's not early in life, it's not end in life, or sorry, towards the end of its life. It's what a lot of the stars, excuse me, in the entire universe look like. So for our ability to study something so close to us, gain an understanding, and then apply that knowledge to a lot of those other common stars in the universe is very helpful for science. And I think it's just a really neat kind of opportunity or option for us here on Earth to learn about stars and kind of see how they work. It's basically a giant like kind of nuclear reactor producing energy and heat and burning obscene amounts of matter away or as part of its process to function.
So
So I don't
what
know.
does it look like? So when you're looking at it through the hydrogen, it's hydrogen alpha, correct?
Yes, yes.
And I've looked through your scope, which is a brilliant scope. What is your telescope, first of all, and what does the sun look like through it exactly? Like what kind of features can you see exactly through?
Okay. So the hydrogen alpha that I have is made by Lunt, Lunt, and it's a 35 millimeter telescope. So it's very small in terms of aperture, but because the sun is so bright and so close, you really, you don't necessarily need large aperture for it. But when you're looking through one of these hydrogen alpha telescopes, they're a very specialized filter inside that only allows a very narrow wavelength of light to pass through, which is the hydrogen alpha wavelength. And when you're looking at it, the first thing you'll notice is the sun appears kind of reddish. And that's just because of the light that is allowed to pass. Now, what you'll be able to look at or discern on the sun is a whole bunch of different features, but what usually catches the eye, so along the edge of the sun, you'll see what is known as prominences. And these prominences are the sun kind of ejecting matter into, I guess it doesn't really have an atmosphere, I don't believe, but off the surface of the sun. So they kind of looks like, well, they come in various shapes, sizes, and structures, but they kind of look like little flamey fingers sometimes. Now, what is also interesting about these things is they evolve over short periods of time. So if you're observing the sun, say throughout the course of a Saturday, what you see in the morning may look different in the afternoon. And that's kind of fascinating because a lot of the stuff that we look at through our telescopes really doesn't change over time. Because of the scale of the universe, we really don't live long enough to see some of these changes.
Oh,
So yeah, it's kind of a neat thing.
Yeah, so moving out from the sun, we have the set of now 9 planets. Of course, when we were much younger, it was well, we have 8 planets, then we have a bunch of dwarf planets now. Pluto having been demoted to dwarf planet status a number of years ago. So we have the interior planets, the terrestrial planets of Mercury, Venus, Earth, and Mars, and then we have the gas giant planets of Jupiter, Saturn, Uranus, and Neptune. Make sure I get those correct, eh? Off the top of my head.
Yes.
And this really forms our solar system. And the part about this is that we've only really just explored the solar system as far as the probes go. Like we've sent out probes to all of these planets, and including Pluto now, and I think on its way to some Kuiper Belt objects. But this is really very much within our neighborhood, our solar system neighborhood. But going out one step, you kind of referenced this a little bit when you were talking about the sun. We talk about our interstellar region, and that includes like the nearby stars, which includes Alpha Centauri, Proxima Centauri, Barnard Star, and a bunch of other stars like that. And those stars are very close to us. Now, some of them are quite bright, and you can see like those of the Alpha Centauri system, but many of them are faint, and it just has to do with how bright the stars are intrinsically. And all of the stars and that we're looking at up there that you're going to see in the nighttime sky, these are all part of the Milky Way galaxy. So we have and many other planetary systems have been discovered around stars, but all of those stars that you look up at the nighttime sky, even from a very dark site, these are all going to be in the Milky Way. Anything to add on that, Shane?
If you were to put some of the scale into context, so you started with the Earth, talked about the solar system, the interstellar neighborhood, and then the Milky Way. How big is that? What kind of scale are we looking at here?
So the whole Milky Way, I think it's like, like something like 120,000 light years across or something like that. So it is so huge that we use these numbers called astronomical units. And an astronomical unit, I think, is like 93 million miles or whatever it is. It's the distance from the Earth to the sun. And so if the Milky Way galaxy is, like 120,000 astronomical units across, I mean, that is just this massive, massive distance out there in space. But you can kind of get lost in those numbers. And I mean, I could even do that off by a scale. And the numbers actually aren't even so well known. I mean, they certainly have pinpointed them down, but every once in a while you hear like that will change like pretty significantly. So I could be remembering old data from my youth, and
Sure.
certainly things change. But the one thing I want to mention and reiterate is that all of the stars that you will see, even through a backyard telescope, which has one exception here in a moment we'll talk about, are in our Milky Way galaxy. This is our home. What Immanuel Kant referred to as our home island universe, which are all the nebulas and star clusters and all that kind of stuff. Basically, it's more or less the realm of the backyard astronomer, with the exception of other galaxies, and in particular our local group of galaxies, of which one is rather bright and prominent, and that is the Andromeda galaxy. And there's some other galaxies up there like M33 and a few dwarf galaxies, but these are their own sort of areas in space with their own stars and nebulas and clusters and everything all on their own. And as mentioned, when they look up into their night sky, if there's beings in those galaxies, the stars that they would see in turn would only be the stars in their galaxies. Now, if you were in our Milky Way galaxy, you looked up, now the stars might be in different spots, but we might be looking at the same stars as other beings. And if you're on the other side of the Milky Way, you might be looking at completely different stars, of course, in the nighttime sky. And then as well, like the patterns, of course, will change just depending on your perspective from your own point in the universe. But one night, you and I actually looked at stars in a different galaxy. You had your 12-inch telescope down in the grasslands. We had a really good night, and you actually hunted up, I remember, a globular cluster and some other objects in the Andromeda galaxy. Do you remember that night?
Yeah, that was a phenomenal night. Well, grasslands itself is a phenomenal place to observe. And we had a night of outstanding conditions and decided to put the 12-inch telescope on Andromeda with some really high power to see if we could pull out some of the brighter clusters. I think the bright one is like the catalog annotation is something like G32 or something like
Something
that,
like
or
that, yeah.
yeah, I can't remember. So
You
don't
had
quote
like the
me.
whole book on it, though. I remember you found like a book somewhere, like an old library or something like that, and
Yeah, it's an atlas for
yeah,
the objects within Andromeda that, or some of them are reachable or viewable just with the naked eye with large aperture optics. I don't believe our little refractors, even our big refractors, our 5 inches would be able to resolve anything there. You really do need some heavy duty telescope to be able to pull that stuff in, or get into some astrophotography to really start to, pull that light in.
yeah. But outside of that, I mean, really, there's not much we can see in other galaxies. You might see some star forming regions and that kind of stuff, but they're going to be really small and require a fairly substantial telescope to take a look at. But outside of this local group, we're going to get into the Virgo supercluster, and that's kind of where you get into things like Markarian's chain, which is a big group of galaxies up in the constellation Virgo. And you and I actually we've looked at that a few nights. You can see that in a small telescope.
Yeah. And the Virgo supercluster is probably one of the most humbling observations that I've had at the eyepiece. So, as you carry on here with your tour through the universe, um, it's almost impossible to comprehend how big everything is in the universe, and the distance and the scale of all of this stuff. When we're talking about, and you mentioned already, what is observable in our night sky, we're just seeing things basically within the Milky Way. There's a few exceptions, like what you've talked about with some other galaxies that we can see with telescopes. But for the most part, everything you see is just our one galaxy. And we can't even see all of that. We're really kind of just seeing the one half that we live in. Now, when you extrapolate that there are, millions or who knows how many galaxies in the universe, it blows my mind. And then when you're looking at some fields within that Virgo supercluster, and you can have 5, 6, 7, 8, 9 galaxies in one field of view. And when you start to think about how many stars are in each one of these galaxies, and then the likely, there's for sure solar systems that exist there, and then potential for life, it just is extremely humbling. And
Mhm.
I always enjoy looking at the Virgo supercluster and just kind of panning through that area of the sky. And this is the right time of the year for it too,
Yeah.
because it's kind of a spring object or spring, uh, thing to look at.
Yeah, spring area of the sky. Yeah, exactly.
Yeah.
Moving out from the Virgo supercluster, we have all of the groups of local superclusters. I think there's a Corona Borealis cluster up there, and a Hercules cluster, and a bunch of other ones like that. I think maybe I've looked at one or two of the other ones through large telescopes, but this really gets into the realm of really big amateur telescopes or Hubble type images or large mountaintop observatory type images. And then moving out from there, we have of course, the whole context of the entire universe. But one of the neat things to think about is that, especially like when you're looking through like a medium-sized amateur telescope, like a 5-inch refractor or a 12-inch reflector, is that when you see another galaxy, you look at it edge on, and then you can kind of think about our Milky Way from inside our Milky Way. We're looking at it. And so when we look up into the summertime sky, and we can see that bright, fluffy band of star clouds and basically the aggregate light from other clusters and nebulas and star forming regions and all this kind of coming together. If you kind of think about that in terms of an edge-on galaxy, then go and maybe look at an edge-on galaxy, you can see that around like that Ophiuchus Scorpius region, we have a central bulge, and then kind of sort of tapers off, and there's this big dark lane that kind of runs right down the middle. So I always like to show, and I think you can see this image name where I have this little galaxy, and I think it's NGC 891 up in Andromeda, and then I have like that one of those mosaics that somebody has traveled all over the world and created that show like that sort of band of the Milky Way. And I know you and I have spent a long time taking a look at that. And you've even taken some photos of it yourself.
Yeah. I enjoy the wide field photography of the Milky Way, particularly in the summertime. There's so much structure that a camera pulls in. Well, even your eye, it's quite neat. And another edge on galaxy that I love, again this time of the year, is M104 or Messier 104 or NGC 4594.
Otherwise known as the Sombrero Galaxy.
yeah. All of these things have multiple names and
Yeah.
catalog annotations, but it's an edge on that is very bright. And again, through that 12-inch telescope that I used to have, you can see that dark lane quite nicely in there. And it almost takes on a three-dimensional view through the telescope. It's quite stunning.
Yeah. And it's neat, like with that telescope, it's neat to look at other galaxies. And then with our own like smaller telescopes or eye or binoculars, what have you, we can look at our Milky Way and see clusters and nebulae in our Milky Way that appear, although faint, you can see quite a bit of detail, and way more detail than even the largest telescopes can see in other galaxies. So it's really neat that we have our own Milky Way as an example of something for us to explore with these small instruments. Eh?
Absolutely. Yep.
Yeah. So what are some of the things that we can look at? We can look at clusters, nebulas, and galaxies. And so what these are exactly is these are what we call deep sky objects, or DSOs. And it's kind of neat. I'm one of the contributing authors to the Royal Astronomical Society of Canada's Observer's Handbook. And a number of years ago, I had been writing articles for a few years at that point, and they came to me and said, well, what is a deep sky object? Like this does not appear so much in any kind of dictionary or anything like that of astronomical objects. So we kind of sort of sat around and kind of looked at a bunch of different things, and we came up with some loose definitions and that. But essentially what these are the nebulas and star clusters and galaxies. And for the most part, the nebulas, clusters, and galaxies that we're going to look at through amateur equipment, or what we call deep sky objects. And the shallow sky being, if you can refer to it as that, as the solar system objects like the planets and comets and asteroids that we see in our own celestial backyard of the solar system. So in the winter sky, which is just leaving now, we have a lot of really great open clusters. There's a few in the spring sky, and really the hallmark nebula is the Orion Nebula, or M42 in Orion. And then one of the hallmark, really prominent open clusters is the Pleiades up in Taurus. Both of these are kind of getting towards the horizon now, if not on the horizon by the time we get this podcast out. But in the springtime sky, we have the Beehive cluster, we have the Coma Berenices cluster, and then we have all those galaxies in the Virgo cluster or supercluster that we talked about earlier. And then, of course, if you stay up late enough in the springtime sky, we can see our own Milky Way galaxy. But there are two types of two types of clusters. Shane, what are our two types of clusters?
Well, you already let the cat out of the bag, Chris.
Just winging it here.
So one type is globular. And as the name kind of suggests, it's a glob of stars. I think the origin, and Chris, correct me if I'm wrong, but a lot of globular clusters are kind of roundish and look like a globe of sorts.
Yeah, kind of like a little disco ball of sorts. Yeah.
Yeah. And then the other format, or the other category, is open star clusters, and these are kind of they're all in a galactic neighborhood, and have gravitational influences on each other, but they're not really in any uniform structure or shape. They can be dispersed, they can be extremely wide, they can be compact. They're kind of wild cards.
Yeah, and there's a couple things that I always like to think about when I think about these, and that's that the globular clusters tend to contain really old stars. They can tend to contain really bright red stars, and they're located in a halo around our galaxy, and they're no longer forming in our galaxy of the Milky Way. And they're sort of just they're not on that Milky Way band so much. They're just off of the band of the Milky Way. Typically, there's a few exceptions, but for the most part, they're halo objects. And even when we see them sort of superimposed on that band, it's just our line of sight that's really doing that. Whereas the open clusters, they dominate our Milky Way band. And they contain only hundreds, not tens of thousands of stars like the globulars do. They're irregular shape, and most of the time they're kind of coming apart, and their constituent stars are going to sort of go and drift around the galaxy there. So talked about the Orion Nebula. The Orion Nebula is a star-forming region in the constellation Orion. So kind of once you become familiar with the nighttime sky, you find the belt of Orion right below the belt of Orion. There's a long set of stars, and one of those stars in that middle of the set is the Orion Nebula. It's a star-forming region, and it's forming a pile of stars. They're going to, gradually they're being formed into a bit of a cluster there. Part of that is the trapezium cluster. And eventually the nebula will more or less shut down its star-forming process, and then these stars will kind of drift out in and amongst the other stars of our Milky Way. We have other types of nebulae, though. One of them is the M1 Nebula. So do you want to talk a little bit about M1? I think you've probably looked at it more than I have.
M1, I have looked at a few times, but to be honest, that one I don't look at a lot. And I don't know why. I just don't go to that part of the sky, I guess, enough. But M1 is the Crab Nebula, and I believe that this is a star that went supernova. Was it 1000 BC?
Like just over 1000 BC, something like that. Or sorry,
80, right. And what's very interesting about that is there's a number of recorded observations of this when that star went supernova, that people would see it during the daylight. It was so bright. And now we're just seeing the effects of that supernova. And so a supernova is when a star reaches a certain age that it essentially explodes, or it sheds a lot of its matter off into space. And what happens sometimes is we're left with a nebula, this gas that's illuminated and takes on some really interesting structures and sometimes colors. And as far as the scale of the universe, going back 1,000 years is about as recent as it gets. So it's kind of neat to be able to watch this thing as it changes and evolves.
Yeah, and I think that, like, even with Hubble and some other large telescopes, they've done like time lapse sequences where you can even see like the pulsations from the pulsar, which is the stellar remnant from that supernova over about 1,000 years ago now, anyway.
Yeah.
And we talked about the Andromeda galaxy, which is about the brightest galaxy that we can see outside of our own Milky Way galaxy, and you can find that by running a line between Andromeda and the W of Cassiopeia. But we've talked enough about that. But how do you go about finding all of these nebulas, star clusters, and other galaxies? The one thing that I learned very early on is to use my fist. And you can do this by holding your fist out at arm's length. And the size of your fist held out at arm's length is approximately what we call 10 degrees on the nighttime sky. And we can actually use this to kind of sort of plot our path through the stars. So, for example, one of the things that we can do is find Polaris. And you can use your fist, and Polaris is the North Star. And the North Star is the star that sits approximately over our North Pole, and the entire sky seems to rotate around it because our polar axis from the Earth seems to project up through the celestial sphere and right through or very near Polaris. So all the stars seem to rotate around it. So Polaris as a star doesn't move in relation to the other stars. Everything moves around it. And to find it, all one needs to do is to locate the Big Dipper asterism as part of the Ursa Major constellation. And you can go out of the bowl 3/5 or about 30 degrees, the fist being 10 degrees held up at arm's length, and that will actually land you on Polaris. And then one of the other things is that with the fist being 10 degrees, you can kind of subtend down from that to kind of get smaller figures, like half a fist would be 5 degrees, and a finger would be about, like your index finger would be about a degree or so. And then you can kind of use that to navigate around. Now, if you read other things, they'll say like use like these weird and different hand signals, but I can never remember all those hand signals. I don't know about you, Shane.
Yeah, me either. So I stick with the 10 degrees and the 1 degree with the finger, and that's good enough to get me into the ballpark or the neighborhood or the area of the sky that I want to be in, and then I can just use my eyes to find what I'm looking for.
Yeah, exactly. And I mean, really, like, how often are you going to trace out a pattern much larger than a few fists? Well, considering that from the horizon to overhead would only be 9 fists, and one would never do that. Really, that's not much of a stretch. And typically, you're doing maybe a couple fists or so as far as a measurement goes. So.
One other interesting little fist thing is if you hold out your fist or kind of the width of your hand, that represents a half an hour of movement for the sun in the sky.
Okay.
So if it's getting towards the end of the day and you're wondering how much time you have until sunset, just count how many hand widths between the sun and the horizon, and that'll give you sunset.
Yeah, and again, one should never look directly at the sun. So
yes.
Approximate measures.
Approximate.
Good stuff. And by finding the North Star and the North Star not being a moving target, like once you know where it is from your observing location, you can always get oriented. And then you can actually watch as the Big Dipper sort of travels around that North Star from season to season and night to night. For example, in the spring now, we have the Big Dipper high up overhead, and it's pointing down towards Polaris. Once we get into summer, it will be sort of swooping down, and the bowl will be sort of pointing down towards the horizon. As we get into autumn, the Big Dipper will sort of be just skirting the northern horizon, and then once we get into winter, it starts rising up bowl first into the nighttime sky. So you can kind of get a feeling, and by knowing where that Big Dipper is and in relation to some other stars, because we know where the Big Dipper is generally from night to night, depending on the season now, you're going to be able to find the North Star by using the Big Dipper and going out from the bowl 3 fist lengths. And then you can actually arc from the handle of the Big Dipper down to Boots, and you can go down from the bowl to Leo at this time of year, and then sort of in between we have Virgo, and you can kind of sort of use that as your guide and sort of make your own rules for finding some of the other stars and constellations. Anything to add on that, Shane?
One thing that I found helpful to learn some of these constellations as well as their locations in the sky is you can get these little planosphere things, from various sources, bookstores typically or astronomy stores. And they're pretty easy to use once you figure them out. You just set the time and the date just by rotating a disk inside of this planosphere thing. And it shows you what the night sky looks like on that time of the year, wherever you are. And they're helpful just to locate constellations and understand what's going on up there.
Yeah. Did you use one of those to kind of start learning the nighttime sky when you were learning it?
Absolutely. And I got to be honest, I still use it sometimes.
Really?
Yeah. Because there's some lesser, like kind of the minor constellations that I just don't spend a lot of time with. Sometimes I find it helpful.
Yeah, I never did. The first time I ever used one was when we started like giving them out for our public outreach events as like those cardboard star finders.
Oh yeah.
That was the first time I ever really held one in my hands. I'd sort of heard of them before, but it was one of those things where, I'd heard of them and that, but I'd already been learning the stars and that for so long that I kind of knew like most of the constellations and that, and like when they were up and everything. By the time I really found out what a planisphere was, because although I did learn in my late teens and bought some books and that, I'd kind of been tinkering around with it since I was like 7 or 8 or something like that, and sort of knew where, Orion and Canis Major and the Big Dipper and, many of those constellations were more or less, and kind of had filled in a lot of gaps once I started really kind of buckling down and reading about it. And then kind of when I started reading about these planispheres, I was like, well, I kind of more or less am pretty comfortable with all these constellations already. I'll just kind of skip that as an accessory, right?
Yeah, yeah, no, for sure. Again, your mileage may vary. Some people, it might help you out. So consider
Yeah.
that if you're new to the night sky.
You know what I used? I'll tell you what I used instead is, like I said, because, well, and I had a bit of a jump, because where I was, there was a lot of very older and advanced amateur astronomers, to say the least. And so I was able to kind of go out and, I would learn a lot from them. One thing I ended up getting instead of something like that was I bought one of these Messier cards, these laminated Messier cards it has all the constellations. And I kind of knew which constellations would be up at different times of the year, and I knew many of the constellations, but I would refer to that. And then, of course, it has all the Messier objects marked on it. So I was both looking at that, knowing what was up, and then finding all these Messier objects, just for fun at that point, because I'd seen most of them already before I really got so dedicated to doing astronomy.
Yeah, yeah, lots of resources out there for sure.
Yeah, but yeah, I mean, that, I guess that would be one other thing, and I never really thought of that before. And do you have one of those Messier cards?
I don't. No, I don't.
I've got a few of them around here. Like, I have so much stuff. Like, every once in a while, like, magazines would like include them as an insert. I'd buy an extra one and tuck it away, and I never bothered getting them laminated, but I do have my laminated ones still. Of course, it, very quickly I inadvertently like folded it between something or put a telescope on it, so
Right.
it's in a little rough shape. So I'm going to talk about kind of like a few of the directional points with astronomy. So these points are more or less always the same. When you go out under the nighttime sky and you look straight up, this is the zenith point, no matter where you are. So if you're in middle of Canada like we are, and you look right up, we say that's the zenith. If you go down to Florida, and I've down to Florida to do astronomy, and I look straight up, we also say that is the zenith. So if we're out doing astronomy, whether we're in the middle of Canada or on one of the keys in Florida, and we see a satellite going through straight overhead, and I say, hey, I'm seeing satellite, and somebody would say, where is it? I'd say, well, it's going to pass the zenith here in a few seconds, so just look there. And everybody would know that I'm talking about the point straight up. Then we also have the celestial equator. And the celestial equator is just Earth's equator projected out onto the celestial sphere. Now, there's another point, and that is the ecliptic. And the ecliptic is a little bit hard to kind of wrap your head around, but it's the point where the planets live. It's not really a point. It's like this imaginary circle that goes around the Earth. Often people will get the celestial equator and the ecliptic confused, but the equator really is just the equator projected out, whereas the ecliptic is the path of the planets, and of course where eclipses occur. And the ecliptic can it spends part of the time, half the time above the equator and half the time below, and that's like, in essence, why we have like summer and winter and all that kind of stuff this seasons, because the sun rides along the ecliptic as well, giving us those seasons. And of course, the whole thing rotates around the celestial pole, and you kind of get a feel for that. Like, I don't really think that much about the celestial equator when I do astronomy, Shane. I don't know about you.
Not a lot. It's when the planets are out, I kind of trace that out with my eye. When there's 2 or 3 planets spread across the sky, it makes it a lot easier to visualize it.
Yeah.
And then again, it's just it's an interesting thing to think about, in terms of, hey, that's the plane of the galaxy or the solar system where
The
everything is kind
celestial
of rotating.
the ecliptic, being that plane, and seeing it rise and fall, and of course that has to do with the tilt of the Earth. But the other point, and this point took me a long time to kind of learn, this is something I learned later, is the importance of the meridian. So the meridian is the point similar. Well, it's a line, and it has to do with the zenith and the anti-zenith point, which would be the nadir, which is the sort of or the southern spot, which would be straight below you. And if you draw a line between the point directly overhead and the point directly below you, sort of cutting from north to south and looking south, that would be the meridian. And the reason why the meridian is important is that this is the point in the nighttime sky where objects will be highest above the horizon and be best viewed. And so sometimes, not always, but sometimes we'll have like a planet, and when the planet is at opposition, we're going to want to look at it when it's at or near the meridian to get our best views. Of course, you often can't be picky, and often, maybe the dates around the opposition aren't that good, and so we do sort of observe around that. But like, for example, in the summer, the best time to view the Milky Way is the end of June into August, when it's close to the meridian. And this is one of those things that it's worth looking up, and it's worth learning a little bit about, because I've often found that people do learn a little bit late, and then I go out and there's one observer who comes out with us that hasn't been observing as long, and that individual sometimes pick deep sky objects which are nowhere near the meridian, which had been near the meridian maybe 2 or 3 months before, or will be at the meridian in a couple more months if we're looking at the orange or the morning sky as the sky is turning orange. And I keep saying, well, don't look at that now. Like, look at whatever it is. So, for example, if we're going to this time of year, they might be looking at, I don't know, like the Andromeda Nebula or something down in Canis Major, which is really low on the horizon. Whereas I might be saying, well, you should be looking at the Virgo galaxy cluster because it's really high. It's near the meridian these nights, or something like that. So, any comments on that, Shane?
Yeah. Just to distill that down, anything you're looking at in the night sky, the higher up in the sky it is, the better. That's what you want to look at, because you're looking through less atmosphere, Earth's atmosphere, which causes distortion. So we're always looking for things that are a little higher, because that'll be the best view possible.
Yeah, and that's the whole point. I guess I should have mentioned that. So it's a good thing why I have you here. Yeah, exactly. So it's nice and high. So it's above the sort of murk and the denser part of the atmosphere, so you can see a little bit deeper on it. And then you can also observe it for longer. So and that's the one thing I was thinking about maybe, is that once things get close to the horizon, if you're observing, like, I don't know, like we're getting towards the end of April now. If you go out in the evening and start looking at something like M93, which is an open cluster just below Sirius, in the constellation Canis Major, then it's going to be a very short-lived observation of that object as it gets down to the muck and disappears or goes over the horizon or what have you. Versus if you're trying to hunt up something in Virgo right now, it's nice and high. You're kind of going to have like all evening or most of the night to do that. And you can kind of sort of take your time in that. So, but I do see some. I don't want to say beginners, because it's typically people a little bit more advanced than that. But people who are just really getting into deep sky observing after maybe a few years of doing it will sometimes still go for those sort of lower objects. And there's so much to look at in the nighttime sky that there's no point in doing that. You're just making things extra difficult on yourself, and then you're although I don't want to discourage anybody from doing any kind of astronomy, I think that it's best to kind of try to have a bit of a plan anyway. So
yeah, for sure. It's it's some effort to haul all of the gear out to a dark sky site and then set up, and all of those factors mean maximize your time looking at the best things possible.
Yeah. Sounds good. Anything else that you want to add to this podcast, Shane? I think we're pretty much at the point of wrap up.
Yeah, no, I think that was a great overview of everything up in the sky and
the universe.
Looking forward to the universe. Yeah. No, I think it was good. I'm looking forward to the next one already.
Good stuff. All right. Well, we'll talk to you next week, Shane. I'm just going to stop this.
Thanks, Chris.